So today's lesson is called Exponent Laws Day 1. The previous video was just a review of concepts that hopefully you did pick up, but it's there just in case you didn't learn them last year or you just don't remember them from last year. Okay, so now I'm just teaching you a couple more laws this year on one's zero exponent and one is what to do when you have a negative exponent, okay? But to start off with, we're just going to do a little investigation to kind of ease ourselves into this law, and hopefully that it will help you remember the law better. Okay. So what for the first one, just you just have 3 divided by 3. So what's the answer to that? So um, honestly, whenever in doubt, just try it on your calculator, just refresh, because a lot of you sometimes will write 0. Okay, this is 1. Okay, it's 1. So, so from there, I want you to do this question again, though, using exponent laws that you picked up or we reviewed last day. So you know that they both have an exponent of 1, right? When you don't see the exponent there, the exponent of 1 is there. So what are you supposed to do when you divide exponents with the same base like that? You are allowed to subtract. You rate the base once and you subtract the exponents, and you end up with 3 to the 0. So you know that the 3 divided by 3 is 1. Okay, so you know that it's 1. But if you're using exponent laws, you get this number. You get 3 to the 0. So that answer is 1. Okay, so that's the connection I'm trying to show you today. All right, so whenever you have an exponent 0, the answer is 1. Okay, so again, but you got to just keep in mind that that 0 owns the number it's beside, okay? All right, here's the next one. So again, this is 2 to the 1. So again, if you're just calculating it out using BEDMAS, you know it's 2 to the 1 is 2, 2 to the 1 is 2, so 2 divided by 2 is 1. So you know the answer is 1. If you're using exponent laws, this is what you're doing. You're subtracting the exponents, and then you get to 2 to the 0. Okay, and 2 to the 0 is 1. So whenever you have an exponent 0, that's 1. Okay, so doing BEDMAS and then getting to here, same thing, you should get to the answer of 0 or 1. Sorry. Okay, so here's the next one. Again, so if you want to just to not, just go right to the exponent law here to practice it. Okay, so you're subtracting those and then you get an exponent 0, so the answer is 1. All right, same with this one here. Even though it's negative 5, you know that they both do have an exponent 1. So you're subtracting that, and you're getting a 0 exponent, which will end up as 1 as well. Okay, all right, so that's hopefully kind of a connection as to like a good way for you to remember, oh yeah, whenever I have an exponent 0, you should be getting the answer 1. But when it comes down to it and you're, a little bit tired one day and you're trying to figure out yeah, just like what was that law again? Was it 1 or 0 and so forth? So you can just, go 3 divided by 3 like that. Okay, whatever helps you remember, because a lot of you will write 0. So I just want you to make sure that you know that a number divided by itself is 1. Okay, so all right, so let's make a conclusion here. Okay, so the conclusion here, summary, whenever you have a 0 exponent, the answer is 1. Okay, all right, so again, but this applies to you looking at if the exponent is on that number, like 3, then it becomes a 1, okay? But if it's, you have some other stuff on there, then you have to be careful. So we're gonna look at some examples now. All right, here's the general rule here. So yeah, so any non-zero base, so you can't have a base that's 0, because then it just won't work. You are looking at the answer will be 1 when the exponent is 0. Okay. All right. So here's the first one. So again, we're looking, and this 0 exponent is attached to this number. Okay. So this is 358. So it's attached to this number. So the answer is 1. Okay. Even if it's a letter, the 0 is attached to this x here. So 0 exponent, answer is 1. All right, so hopefully you're starting to see a pattern here, even if it's some really, really large number here with the exponent little 0 up in the air, 1. Okay, so now we're getting to some other things attached like brackets and so forth. So again, whenever you have an exponent on the outside of brackets, it means it kind of belongs to everything in here. So if you wanted to do this the long way, you can think of it as, well, there's a 1 on this on the 6, so an exponent 1. The x has an exponent 2, so if I have the 0 outside, so you've seen this last day where you are going to multiply this exponent in, so it'll be like 1 times 0. And then this x squared is times 0. Okay, all right, so then that ends up with 6 to the 0. And then this becomes to the 0. And anything to the 0 is, right, that's 1. And that'll be 1. So the answer is 1. Okay, so if you have a 0 on the outside and there's a bracket, so it doesn't matter what's inside of here, this whole thing goes to 1. Okay, here's the next one. So again, you can go and square it, like use BEDMAS and square them and go 9 divided by 9. Oh, that's 1, right? Like that's what you would do here. 9 divided by 9 equals 1. Okay, or you can use your exponent law. So whenever you divide something with the same base, you know that you subtract the exponents. So you get exponent of 0, which is 1. All right, same with this one. It's similar to D, right? There's a 0 on the outside. I have it here, again, it's similar to D, because I want you to see the difference between F and G. There is a difference here, okay? All right, so we have this all inside the bracket, so all of it gets wiped out and becomes 1. All right, but in this one here, it doesn't have a bracket. So take a look carefully. So think of it as, right? The 0 exponent is only on that x, not on the 5, okay? And then BEDMAS will say, you know, do the brackets first. Okay, there's no brackets. Do the exponent next. So you have to take care of this x to the 0 first, and you leave the 5 multiplied on after, okay? So till after. So x to the 0 becomes 1. So the final answer is 5. Okay, so be careful with those ones. Just kind of pay attention to where that exponent is attached, okay? If it's in a bracket, it means, okay, everything in the bracket is controlled by this exponent 0, okay? Where here, you only had the 0 on the x. So the 5 just waited outside. X to the 0 happened, became a 1. And then it had to multiply with the 5 to give an answer of 5. Okay? All right, so that's those are the 0 exponents. So again, don't go, I don't know, and assume it's multiplied by 0, okay, and then you end up with the answer of 0. No, the answer is 1. All right, here's the next one, the negative exponent. So whenever you say negative, just think of it, we can't have things as negative exponents, okay? So we have to change it so it becomes a positive exponent, and then from there, carry on with the question. So you're looking at this rule here right now, and you're saying x to the negative a, so we can't have that. So what's happening here, you can think of it as, like, you know, there's a 1 underneath here. So what we do is we flip it, and when we flip it, so this x to the a goes to the bottom, the exponent becomes positive, okay? And then it's the same if, what if you started with a negative at the bottom, like that? So same thing, you flip it, and then it'll be positive, okay, like that, and then you don't write the 1 underneath, so it'll be x to the positive a. Okay, so this is the negative exponent rule. So we are trying to get it out, get it away from the negative exponent. All right, so again, here is 1, 2 to the negative 3. We have a negative exponent. We don't like that. We can't evaluate until we have a positive exponent. So think of it as being having a 1 underneath, right, if there's no number there. And then now what we're going to do to correct the negative exponent is we're going to flip it. Okay, so it becomes a positive 3 exponent like that. And now we can evaluate it. 2 to the 3 is 8. Okay. All right, so again, don't think of it as 2 times negative 3 is the answer is negative 6. You're not multiplying here. This is an exponent, negative 3. All right, so let's do the same thing here. So we have a 1 underneath. We're going to flip it. Okay, so we get to there. Yeah. And we get to our answer here. So again, if you've seen this before and you know how to work with these, you could try a few examples below quickly and then move on to the next video. Okay, but otherwise, I think it's always good to kind of refresh our memory when it's been a while since we've used these. All right. So yeah, so I flipped it, I made it a positive exponent, and then I evaluated. All right, so here we have a negative exponent again, and then we have a fraction inside. Okay, so what have we been doing with all of these in order to correct for the negative that was out here? We flipped it. So the same idea works here, even if it's like an actual fraction, you are going to flip the fraction, okay? And when you do that, that's going to correct that negative, make it a positive 4 like that. Okay, so I know like the negative, the exponent ended up moving down and so forth with these other ones, but with these ones, just flip it and then leave the 4 as positive here. Okay, same with this one here. Oh, sorry, let's evaluate this one. So then from there, the rule is you can put the exponent 4 on both of them. Okay, like that. Okay, and that becomes 81, and that becomes 16. Okay, and don't think that can reduce. Nope. Okay, so we'll leave it like that. Okay. All right, same with this one. Let's flip it. Oops. So we'll bring the y up first to the top, the x to the bottom, and that will correct the positive, or so the negative 5 to make it positive. And then we're just going to put that exponent in. So y gets to the 5 and x goes to the 5 like that. Okay? All right, so now that you've seen those two laws, so that's a quick little lesson on those, I want you to apply everything that you covered in the review and these two new laws, the zero and the negative exponent, and tackle some questions. All right, so let's go through and practice some of these together, and then hopefully by the end of this practice you'll feel a little more comfortable, and then you can practice lots of questions and then try the checkpoint, okay? All right, so again, 0, that's our first new rule. Okay, so that 0 belongs to the 5, so 1, 3 to the 0 here, same thing, 1. Okay, so don't write 0, don't write 0. All right, even if it's an x, okay, it becomes a 1. All right, all of this stuff here, we're going to even a negative that you're starting to stress out about because you can't use negatives and so forth, but in the end, all of this is controlled by this exponent 0. So it doesn't matter what's inside that bracket, okay? It could be cats and dogs and lollipops and whatever else. This all becomes 1, okay? All right, here's a division type question. So 8 subtract 8. Okay, we could think of it as, well, these are the exact same thing, so I would just cancel them out, and my answer is 1, right? So that's what you would do in the past. Okay, but now you end up with, like, if you clean it up with exponent laws, you get to 4 to the 0, which becomes 1. All right, so again, we're kind of combining all the exponent law tools that we picked up. So here, I've always taught you clean up the top of the fraction here and then divide it, okay? So in this case here, they're being multiplied together, so that means I can add the exponent. Okay, so again, if you can do this in your head and just write, oh, that's 5 to the 15, and this is 5 to the 15. Oh, wait, they're the same. You're subtracting the exponents. Again, you don't need to write all this work, but if you can tell that it was 1, then you write 1, okay? All right, okay, so those are some zeros. Okay, now we're getting to some negatives here. So negative exponent right away, you're just like, nope, can't, we gotta fix that. Okay, so we're gonna flip it. Okay, and then it becomes positive 4. And then 3 to the 4 is 1 over 81, and just leave your answer as a fraction. Okay. All right, same with the next one. Get another negative exponent. So again, if it helps to write this one underneath, do it, and then flip it. Okay, the 6 still stays 6, okay, but the negative 7 becomes a positive 7, and then 6 to the 7 is a really large number here. Okay, there we go. And then just leave it as a fraction. All right, here is one that sometimes you're so used to seeing, if you see a negative now, you got to fix it and so forth. You should only do that if it's the exponent, okay? So here we have a couple negatives. So you're worried about maybe this one, like, oh, it's negative, we got to fix that. No, it's just the exponent 2 that's a concern here, okay? So what we're going to do here is, again, rewrite the 1 like that, and we're going to flip it. So when we flip it, this negative 4 is still negative 4, okay? But the thing that changes when we flip it is the exponent 2 becomes, the negative exponent 2 becomes positive 2, okay? And now you go through and evaluate, and you're like, negative 4 times negative 4 is positive 16. Okay, so that negative on the 4, don't let it disappear. Okay, just because you flip it, it doesn't become positive. It's just that exponent that changes, okay? All right, same with this one. Even if it's letters, be able to handle them, okay? Flip it. Okay, then you get x to the positive 5, 1 over x to the positive 5. Okay, and that's as far as you can go because we don't know the value of x. All right, here's one where the negative exponents are at the bottom of a fraction. So again, all you do is flip, becomes positive. Right, and then that 1 goes to the bottom, but then we don't write the 1, we just write it as x to the 4 like that. Okay, all right, so this next one, we can do it lots of different ways. We can use, you know how they're multiplied together, so you can use the multiplication law. You could fix the negative first and flip it and so forth, but what I'm going to do here is I'm just going to use the multiplication law first, so I know they have the same base, so I am allowed to add the exponents. So when I do that, I will get negative 2. Now I'm going to take care of the negative. I'm going to flip it, make it positive 2 exponent, and then I'm going to evaluate it to the 16, 1 over 16. Okay, so again, if you wanted, here, if you did that a different way, I'll just write it in a different color here. So you could have gone and you could have flipped it. So you ended up with 1 over positive 5 like that. So then when you combine them, it's the same as going 4 over 3 divided by 4 over 5, which ends up being this step here now. You're going to subtract the exponents and then get to your answer. Okay, so yeah, just because we know a lot of different tools now, there's a few different ways that you can go about getting to the answer now, okay? All right, now just kind of, again, ramping up a little bit, just, again, think about BEDMAS, think about the exponent laws, and slowly work your way through here. All right, so we have a negative 4 times x to the 5 times y to the negative 2. So again, just a reminder, this negative 2 belongs to the y. Okay, it's not on the x, it's not on the 4. This x to the 5, this 5 exponent is only on the x. It's not on the negative 4. Okay, so I want you to go through and I want you to clean this up. So you're thinking, well, I can't multiply these numbers together, but the problem here is just this negative exponent. So let's clean that up, okay? So we know that there's a 1 underneath. We're just going to flip that. Everyone else we're just going to rewrite. Okay, so there it is. And then if we flip this one, it becomes that, y squared, like that, okay? And then if we rewrite it, it's like all over one fraction, right? So you can think of it as negative 4, x to the 5, all divided by y squared. Okay, so again, we can't do anything with the letters here, but this was an issue here because this exponent was negative. So we just had to fix that, and then that's the better answer that you need at the end. All right, let's go through here. Negative exponent again, how do we fix it? We just flip what's inside, regardless of what is inside. So the y goes to the top, the x squared goes to the bottom, then we end up with a positive exponent like that. All right, and then from there, we want to just put that exponent 3 in, so that becomes y cubed. And then here, it's, remember you're just multiplying when the 2 exponents in the air, so this becomes x to the 6. What I want you to do is please practice these. There's so many different types of questions that you can get thrown at you that if you just kind of practice them, you'll get to really comfortable and confident with the laws, and then with the 2 new laws, the 0 exponent and the negative exponent.